Hello and welcome everyone. Stefan Burns here reporting from the spaceship. I have been picked up by 3i Atlas last night, sent off a mini probe, swooped in, picked me up. I am here on the spaceship. We are on our way to Jupiter doing amazing things. You are all going to be picked up soon enough as well. If you want to join in on the party up here in space, well, there's room for a select few of you. So hello and welcome to the live stream today. Some new updates on Interstellar Object 3i Atlas. Happy Halloween. This is the 5-minute impromptu costume I was able to make for you all. And if you notice, there's this flashing crystal light at the top there. So this is the best that I could do in 5 minutes. And we are going to report on some interesting developments with 3i Atlas. And a lot of this is actually speculatory. So we don't have like 100% confirmation on these things. The big report that's floating around today is about the non-gravitational acceleration. That is something that we observe with a lot of comets because they are off-gassing, which does change their trajectory, because when you have something off-gassing, that creates force and moves things slightly. So this isn't anything super anomalous in that case, right? The question is, okay, is some sort of acceleration or shift in an orbit just from natural causes, or is it, someone turning an engine on? That's the thing. So there's no evidence yet that 3i Atlas is technological, other than the fact that I'm on the spaceship right now, folks. It's pretty sweet. They got some cool things here. It's great. The longevity tech is insane. But that is something that has been reported. We have the offsets effectively that's been reported by NASA. Some telescope observations were done on the 29th at the perihelion when 3i Atlas was closest to the sun. That does not mean that it was behind the sun. It's Earth, Sun, and 3i Atlas behind the sun but slightly to the side. So we were able to detect it with a millimeter array. But that we did get some measurements, and that shows that there was some non-gravitational acceleration. Also, though, we have been hitting 3i Atlas, or rather the sun's been hitting 3i Atlas with tons of solar flares and coronal mass ejections. And so I did some research into that, and I did some research into the plasma dynamics of comets. And turns out ESA did a very big and well-known comet mission back in the 2010s, the Rosetta mission. And they gathered some incredible data on C697CG. And this is a comet, it's a Jupiterian comet, and it flies around in between Jupiter and our solar system. And I think it makes a loop about every 5 years or so. And we found some really crazy stuff with this comet when it got close into the sun near its perihelion. This is back July 2015. Its perihelion was August. It got hit by a coronal mass ejection just like 3i Atlas did over the past few days, over the past week. It got hit with one, though, of really big caliber. 3i Atlas got hit by 4, 5, potentially more. And what they found was that the magnetic field around this comet back in 2015 dramatically strengthened. And in general, we learned a lot more about comets. The simple model that they tell you about in just online or some NASA educational webpage, whatever, is super simplified. And you'll notice a lot of people talking about comets, like 3i Atlas, they never say the word plasma. It's just dust and gas. But for some reason, they never say the word plasma. Meanwhile, the only way you can understand a comet or some sort of interstellar object, anything of that nature, is to discuss plasma, because the moment gas gets released from the nucleus, sublimates, and then it pushes out at hypersonic velocities, eventually cools off, it kind of expands outwards. The moment that happens, it's being hit by sunlight, extreme ultraviolet X-ray light, and so it's ionizing because of that. It's also ionizing because of the solar wind. And you have this charge transfer that occurs between solar wind ions, hydrogen, helium, electrons, and this heavier, more massive dust and gas of the comet or interstellar object. This would be like H2O, CO2, CO, methane, right? These are heavier molecules. And all three of those combine, and then there's also any free electrons that are already very energized can also then hit these heavier molecules, these gas molecules, neutral gas, which is not under the susceptibility of electromagnetic fields, and then that can also cause them to ionize. So you have these three factors all together working to ionize a comet. You get the dust being pushed out from the nucleus around the surface, you know, because that gas is extremely fast in its sublimation. It's coming out at like supersonic speeds, Mach 1, 2, 3, etc. And so that naturally carries some gas and drags it out, the gas drag of the dust. And then the dust ionizes, and that ionization can change quite dramatically. And there's also these instantaneous changes in the voltage of a dust grain because you can only have like 4 or 5 electrons, or maybe it goes from 4 to 7 and then 2. It's always shifting. The average voltage of a dust grain can be positive or negative, about a few volts, but there's this instantaneous fluctuation. Also, there's these significant zones and distinct boundaries and layers to the plasma environment of a comet, where you can have dust grains that are being accelerated at high speed all of a sudden go from an environment where the electric field is like 2 volts to like 20 volts, and that causes there to be a dramatic increase in the electric charge really quickly on that grain, which can cause it to actually explode. Depends on the shear strength of the grain, and so you get these grain explosions, these dust grain explosions. And so larger grains become smaller. Now they're less susceptible to the field of gravity, and therefore they expand out even further. So there's these crazy dynamics at play that causes more ionization because now they're smaller, they can take up charge. And it's like this snowball effect. We saw this all happen back in 2015, and this comet 67P CG, which we'll talk about more, it had a 6 times strengthening in its magnetic field at the cometopause from one big coronal mass ejection impact. 3I Atlas has had multiple. So its magnetic shields have rapidly strengthened as it has displayed non-gravitational acceleration. Again, I do want to just say, A, we don't have direct magnetic field observations of 3I Atlas in a close environment like we did with the Rosetta mission and this comet that I'm referencing, 67P CG. So that would be ideal to really confirm what I'm talking about, but we have the observational evidence, and actually that comet's very similar to 3I Atlas in a lot of ways. We'll talk about that. And then this non-gravitational acceleration, it'd be nice to get some actual research papers published on that and to get like a more detailed analysis, because right now we're just going off of the JPL ephemeris data and the latest observations there and kind of piecing it together. So nothing 100% definitive, conclusive that I can report at this moment in time, other than that the spaceship is awesome. It's great. The snack bar is really great. They have all these weird alien drinks. Yeah, the psychedelic experiences are insane. So the consciousness level is much higher here. And let us get started. Also, a bunch of big super thanks. Before we do, a lot of big super thanks came in. Just want to just quickly give those people a shout out. So Tracy USA, thank you for the big super thanks. That's 149. Another one right there. Lady Montgomery, and then Melissa. Thank you all so much. Some other super thanks as well. God bless you all. Yeah, welcome to the spaceship, folks. Let's start with the latest observations and data and photos that we have of 3I Atlas. That comes from Punch. NASA has a fleet of 4 spacecraft that are kind of always observing the near-sun environment. And this is 3I Atlas from its perihelion, so the 29th of October. I think a few other people have already reported on this. That's fine. Here we see 134 images stacked together. The data that we got, the images that we got of 3I Atlas from the CCOR1 chronograph and the C3 chronograph, and those from back just a little bit earlier in October were better quality. This is pretty blurry and grainy. You know, this Punch constellation is not really made to do this, but we did it anyways. So shout out to Kevin Walsh. He posted this on Blue Sky. And there's a link to this in the video description. You can also just go to his handle. But we see it moving there very slowly. The estimated apparent magnitude is about 9.5. So in that 10 to 9 range, it goes from 10 to 9 to 8 as you get brighter and brighter. And then eventually goes negative as you get really bright, like Venus, for example. So this is about 9.5, which is fairly bright, but not crazy bright. And as it moves further away from the sun, its elongation from the sun increases, we're going to start to be able to take our Earth-based telescopes, like visual light, etc., and actually be able to image 3i Atlas in a very significant way. Whereas right now, we're really limited with our capability, though thankfully we do have eyes on it. So this is our latest imagery of 3i Atlas from perihelion just 2 days ago. Punch is still watching it. The level 0 data, level 1 data takes like a week to come out. Level 0 is instantaneous effectively. So if you really know how to do this, you're a genius. You like to geek out, you could take this data, stack the images yourself, and get some graphics of 3i Atlas, because this is not officially done by NASA. This was done by a good sir, Kevin Walsh. So that's our latest imagery of 3i Atlas. Let's now discuss how you can get, or what's happened effectively with 3i Atlas as it relates to the magnetic field. Because here we see Comet 67P CG, and this is back in 2015 when the Rosetta mission was active. We had a whole mission that ESA planned. They sent a probe to this comet. It was orbiting around it, put a lander down 3 times. And so a whole bunch of observations were made. It got very close to high resolution photos of the entire nucleus, of course landed on it, got samples. And while it was orbiting around, some interesting things happened. One of those is that a big coronal mass ejection launched out in the direction of it. Look at that, high velocity, that's a big coronal mass ejection. Pretty equivalent, in fact, to what we just had. And in general, look at the solar activity that was occurring during this close approach of this comet. Right, it's quite a lot. It's very similar to what happened now. That first one, though, being aligned with the comet. You'll notice that it's pretty bright, and it's moving. It's actually moving this way. We'll check out the sky live view in just a moment so you can get a sense of what this is. But it shows up as a bright point of light. No big tail on this thing, which is kind of interesting because also 3i Atlas doesn't really have that much of a tail, if at all. And the diameter on this is only like 2 to 4 kilometers. So that could be in the zone of 3i Atlas. 3i Atlas could be smaller than that. It could be bigger than that. We don't really know the size of it. It's all just based off of guesswork. So it very well could be around the same size as this comet here. On July 1st, the sun blasted a powerful coronal mass ejection in the direction of this comet, Churyumov-Gerasimenko, and that was currently at a distance from the sun at 1.3 astronomical units. Perihelion of 3i Atlas, 1.36 astronomical units. In fact, it is 1.356. Its perihelion for Comet 67P CG was August, so it got a little bit closer, but never cut within the orbit of Earth. So very similar in terms of its perihelion, which means it's similar in terms of its photoionization, the watts per square meter that 3i Atlas is currently receiving. ESA's Rosetta was orbiting the comet at a distance of approximately 180 kilometers from the nucleus when it passed through the cometopause, which typically is out 600, 700, 800 kilometers away from the nucleus. What they find is that the combination of photoionization and charge transfer from solar wind and electron ionization is non-linear. So you can model these things independently. You get certain distances and such for where you get the ionopause and the cometopause, and we'll look at the diagram next. We can see it right here. We'll look at this guy in just a little bit. But when you combine all 3 of those together, the effects are complex and they're non-linear. So what happens is things actually expand out to a much greater degree than you would think. Now here's the deal. We just had extreme photoionization of 3i Atlas because of all those solar flares, lots of extreme ultraviolet light and X-ray light. We had multiple solar storms hit and the solar wind was strengthened. So you had a perfect storm to cause this thing to just supercharge. And well, what we saw with this comet was that its magnetic field was greatly compressed down closer into the nucleus, where the Rosetta probe was at the time, about 180 kilometers, and therefore it went through a magnetic field that had a strength of 300 nanotesla or so. Normal field strength was 45 to 50. So that's what it's picking up normally, but you get that big coronal mass ejection to sweep by it. Just 2 days later, the magnetic field increased by more than 5 times. It increased by about 4 to 5 to 6 times. So really significant increase in the magnetic field around this comet back in 2015, which we can, I think, pretty safely use as a parallel for what's happening now. But in fact, what 3i Atlas did was even more significant. Let's look at our real-time. It's actually not real-time. This is set for the 15th here of, well, 2015 rather. And, you know, this thing is actually really uncomfortable. So I'm doing my best. On the spaceship, it's not all pure pleasure and paradise. There's still a little bit of suffering here. The headgear is the worst. So here we see our comet, and we see the Earth, and this is set for the 27th of July. Let me go back in time. Okay, we'll go back to the 1st of July, right here when that CME launched off. And you can see how that alignment makes sense. So we have the Earth, the Sun, and then we have this comet off to the right. Okay, so this is to the west solar coordinate system. If I go back one more time, right here, yeah. If you go back right here, see how it's off to the right? Okay, so that's the orbital layout. We have it off to the right. If I go forward in time, right here, boom, boom, we see that Earth is moving its orbit, but it's also going like this, and we'll check out its perihelion right here. You see how it cuts in a bit closer than 3i Atlas does, because if we just look at the orbit of 3i Atlas, not on it, you know, its orbital path is shown, it doesn't get as close, but at that moment right here, pretty similar. So this is 1.36 AU, this is 1.36, this is 1.3, this is 1.36. So that's the alignment. And we had that one big coronal mass ejection that swept by this comet that caused that rapid magnetic field increase. Now here's where things get exciting, in my opinion. Because here we have a good graphic showing all the different processes in play with a comet. And you have to read the research papers to really get these graphics. Like, I've never seen this before. I've done a lot of research on comets, but more surface level. This time I decided to specifically go to Google Scholar and type in comet, plasma, environment, things of that nature, and I got some papers, and then I, did my research on them. And so it's very similar in my mind as to what happened with the Earth. When we first started to imagine the magnetic field of the Earth in space, it was a very simple diagram, and now it's very complex, because as we sent probes to it, we realized it was much more complex than we thought it was. And we use those actual in situ observations to inform what we're seeing now and what is actually happening. So here's our nucleus, here's a rapid expansion of gas, and it creates a whole bunch of things. So you get this gas expanding out very rapidly. It's also carrying dust with it as a result. The gas is also hitting each other, so it's causing it to heat up. So there's this rapid sublimation. Once the gas particles are far enough out, right, they're individual molecules, there's no basically cooling them off and turning it into like ice or something, because it's an individual molecule, it's too energized. You have plasma in space. Just because space is cold doesn't mean there can't be things that are energized. It's actually a very energetic environment with a very low density, right? So if you're in space, the vacuum space is cold, but the energetic particles flying around are very, very hot individually. You get the same thing. This gas expands out. It's a neutral gas at first, but it starts to get ionized, basically almost instantly. There's always going to be some percentage that is neutral, but a lot of it is going to get ionized either by the solar wind, by the photons of the sun, just the light of the sun, or by these electrons that are also already ionized and then hitting new things. This creates this shock zone here and an ionopause. So it's like an ionosphere, but it's an ionopause. It's where you have a lot of ions that are forming around. This thing's moving like this. The solar wind's coming in like that. Well, the solar wind's actually coming in like this in this example. So what you get is as this gas expands out, it's carrying dust with it. It has a lot of mass to it. These molecules, water, carbon dioxide, methane, carbon monoxide, dioxide, everything, right? They are heavy, slow ions. They get ionized. They slow the solar wind down, because the solar wind is mostly protons, electrons, helium. It's fast. It's very energetic. But it goes in and starts to slow down. It causes the magnetic field of the interplanetary magnetic field to pile up. So you get this magneto barrier right here called the cometopause. So you get this magnetic field to form around this comet, And then in this zone here, in between the bow shock and the cometopause, you get what's called enhanced mass loading, where the plasma is getting denser and denser and denser as this fast solar wind comes in. So think about what happens with those solar storm impacts, right? Those are extremely fast waves of plasma coming in to hit 3I Atlas. Oh yeah. Woo, woo, woo. You see my light there, my crystal? Yeah, we're beaming straight up to the spaceship at all times now with this thing on. So you get this enhanced mass loading, strengthens the plasma, causes a whole bunch of very interesting effects. The magnetic field gets very strong. They observed with that impact on July 3rd, 2015, that the magnetic field strengthened to 300 nanotesla. That's really strong, right? The normal interplanetary magnetic field strength is 5. When you get a really big solar storm, it can get up to like 50 or more. The peak interplanetary magnetic field strength that we observed back in 2014 with the Mother's Day storm, May 10th to the 12th, the Gannon storm, G5, we saw the interplanetary magnetic field spike to a total field strength of 73. So they observed 300 nanotesla, 180 kilometers away from this cometary nucleus. Then you get this bow shock here, and that expands out. So the stronger the ionization, the photoionization, the more this electron ionization and the more this charge transfer from solar wind, again, they're nonlinear, it's complex, the more it actually expands out. So what we modeled initially was like, oh, it'll go out like 1,000 kilometers. Like this bow shock goes out 1,000 kilometers. Then we did different combos like, oh, 2,000, 3,000. Then we actually, put all three together and then made some observations like this can go out like 10, 20,000 kilometers. This can really stretch out. So the more active the sun is, the more that 3I Atlas actually pushes out towards the sun. Because here is kind of the real key. A lot of people only discuss space and comets and all this stuff from this like gravitational perspective, and they don't ever include electromagnetism. So again, they're only talking about gravity in terms of how the cosmos is shaped and formed and structured, and how the solar system formed, which is really, it was mostly a plasma dynamic at play. A lot of electromagnetic forces at play with the formation of the solar system. And then also, dust and gas, but they never bring up plasma, and everything gets ionized in space, but they'll gaslight you on that for some reason. I don't know why. Don't ask me why. It makes no sense to me. We're moving into a new paradigm, folks. I guess they're just not ready for it. And I don't claim to be any ultimate expert on this either. I'm not an authority. Authority is the weakest form of evidence, okay? That's the last thing you ever want to just take for, listen to and just take it in and believe, okay? So listen to what I'm saying. If you like it, if you have fun here, and then do your own research, okay? I'll link the research papers that I use to make this video in the video description once I'm done. So here's the key though. The planets, right? The planets have a lot of mass, and Earth has an atmosphere and an ionosphere, and Venus has a very thick atmosphere and ionosphere, and there's Mercury, Mars, whatever, all of them, right? They have a lot of gravity. So everything is held in close to the planet because the gas is very strongly pulled in by gravity. But with a comet, and here we're specifically speaking about a comet, 3I Atlas, comet, interstellar object, whatever, okay? I'm not making any definitive statement as to what it is. It's just an interstellar object in my mind. But with comets, they have very low gravity, super low gravity, but they have a lot of mass to them in terms of things that can sublimate. Like it's this perfect balance of very low gravity, but a lot of active sublimation that's creating these big gas clouds that's carrying dust out. And so it's not really being held in by gravity that much. It's basically just like effervescing like this. There's a little bit that's held on, but in general, the gravity is not doing much. So as a result of that, it really expands outwards. Really expands out. And you don't get that with Earth or Mars or Venus or Mercury or whatever, because they have the strong gravity. So this small object can come in and create a huge zone of electromagnetism. Again, early on reported with 3I Atlas, the Sphere X mission detected this CO2 coma that was 700,000 kilometers across approximately. It's probably only gotten bigger. We really don't know. So, and one thing here to mention too, someone just commented, reports are saying that there's a blue color to it. They were just saying, I read the paper, they were just saying that it was more blue-like than the coronagraph imagery itself. So they detected that it was more blue shifted than the spectrum of the coronagraph, but it's basically still green. I mean, maybe it's changed color a little bit, but it's nothing. A lot of people are kind of misreporting on that. It's not that, it wasn't the big point of that research paper, the fact that it was, you know, having a little bit of a change in the blue spectrum. Okay, so the low gravity means that you get this gas and dust to expand out. It keeps going at a high velocity, like more than the speed of sound, really fast velocity. In addition to that, what happens is you have larger chunks of dust grains that get pulled along, and some of those aggregate together because they take on slight charge, like 1-2 volts, and they'll like slowly congeal together as they're moving out to the bow shock area or to the cometopause. There are different electric field gradients, you could say, in these zones. So photoionization really works in the nucleus area. The light from the sun hits the nucleus. If there's a lot of dust, it doesn't penetrate as deep. So you can get the dust grains that are kind of in the dark, but they're being hit by these electrons to really charge up with a big negative voltage. But then photoionization will go ahead and make the dust grains have a positive voltage. It really depends on where you are. If you're back here, then you can have a negative voltage. If you're more up here, you have a positive voltage. But these things will accumulate, and then all of a sudden they'll hit this zone where the electric field is much stronger, and that sudden change in the electric field, these dust grains are very, very fragile, will cause them to explode effectively. There can be some amount of just grain explosions that occur where you take a big grain, turn it into a small grain. Well, guess what? A small grain is less susceptible to gravity, so now it's floating out even further. So it's this runaway effect where just the fact that this thing is getting close to the sun all of a sudden awakens it and causes all this sublimation, and the dust gets carried as well, and then you slow down the solar wind because it's coming in fast, but this is really heavy and slow, and that all gets ionized, and then it continues to move out and reaches these other electric field and magnetic field gradients that are strong, causing it to explode, expands out even further. So as 3I Atlas got closer and closer in, it also just continuously boom, 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 got more expanded with all these dynamics and was actively pushing towards the sun just as the sun was pushing towards it. It was almost like the painting with God and the finger, you know, and the guy has his finger bent just a little bit like this. Like they were reaching out together, and so it makes sense that there is some dynamic at play where you can have something trigger solar activity in this manner, because this is non-linear. These processes stack together in a non-linear way. It's not 1 + 1 + 1 = 3. It's 1 + 2 + 5 = 50. So a lot of really interesting science there. A lot of it new because of these observations from Rosetta, and what we see often is that it takes some time for these things to enter into the common knowledge. And well, I wouldn't say comet science is common knowledge. Again, I'm no expert or authority here, but you don't see people really talking about this. It's always just gravity, dust, and gas. But you can see how gravity, while it's not the most important force here by far, like all this electromagnetism, it's fundamentally the very low gravity of this comet which allows these things to kind of start. So it's like the initial spark that it triggers everything else. And it's kind of the same in my mind with the universe, the solar system, where gravity is the weakest fundamental force, but it's not completely irrelevant. It's kind of like that base force from which everything else builds off of. So the Rosetta mission was really cool as I've been learning about it. It was the first, second, and third soft landing on a comet. The first one was November 12, 2014. Again, that coronal mass ejection that hit this comet was back on July 3rd, 2015. And there was also an orbiter. And so here's the timeline right there. It was launched on 2004. And then it arrived at the comet 2014. The landing site was figured out and announced. And then there was a landing. And it continued on until eventually there was an end of mission in September 2015. So this is all during solar maximum. So really cool stuff. Here we can see the surface of the comet right there. 4.6 billion years old. Solar system relic, they say. And here is a graphic of it. And they notice also that this sublimation with the gas is very localized. So you can't really resolve the structure of any of these objects unless you get close, because as it expands out, it basically smooths out to a great degree. So it really smooths out. So what you're looking at, you can't really resolve fine details with. So we're probably never going to get a good look at what 3i Atlas actually is unless we send something like Rosetta close in. Like this high-rise imagery from Mars that, it's going to give us a better look. It's not really going to tell us all that much, other than maybe give us a good size constraint. And NASA still has yet to release that imagery. But ESA released their imagery within like 3 days, right? They landed on a comet. ESA is doing some pretty cool stuff. So props to them. Shout out to the ESA. That's what I would say. So we have 3i Atlas right now, basically at perihelion, just a couple days afterwards. Let's go back to our real-time view and let's talk about kind of what happens going forward, because there is a whole story here. So we'll go to today, Halloween. Happy Halloween, everyone. I'm your host, Stefan Burns. What we talk about on the channel is what's happening energetically here on the planet. So there's earthquakes, volcanoes, solar activity, space weather, planetary alignments and resonances, and geometry, all these things, interstellar forces, comets, and more. If you like the sound of that, then please subscribe. I normally don't have the low effort costume on my head here, but it is Halloween, so we want to try. I'm surprised they didn't have better costumes on the spaceship, but they don't really celebrate Halloween. And is this, this is set for 2024. Let's go forward one. Boom, there we are. Okay, so here's 3i Atlas today. Its perihelion was right here. It's now right there. It's effectively in the exact same zone. It's actually getting close to Venus, which just underwent a big increase in its ionization, because most of the solar storms are actually more launched towards Venus than 3i Atlas. 3i Atlas is more right there. So it got hit, but not 100% as hard as Venus did. So this alignment's forming fairly soon. I think November 4th is when that really kind of clicks in. So we see the 3i Atlas Venus Sun alignment there on the 4th. We have the supermoon on the 5th, the full supermoon. So if you go back today though, so it's undergone this dramatic increase in ionization. It's still basically at perihelion. It's going to be within the orbit of Mars, going all the way out. Let's find out right now. Going all the way out to November 24th. It's going to be within the orbit of Mars. So it's going to be energetically working now, as it has been, but it's going to continue to energetically work with the entire solar system, inner solar system specifically, all the way into December. I mean, it'll continue to do so as it goes further out, but really this inside the orbit of Mars is pretty key. Because again, these guys all have a lot of gravity. Mercury, Venus, Earth, Mars, they all have a lot of gravity. So they don't have these big gas plasma clouds, dusty, complex plasma clouds. They don't have them extending super far out like Atlas does or any other comet. So it really is quite unique. And that takes us, again, we'll go here. We have these big sunspots rotating to face Earth around November 7th directly. And then this is 2 weeks later. Where's the Earth right there? 3i Atlas around November 14th, 15th, 16th. Let's go back. Maybe it's more like the 16th. And is this a square formation? No. So around the 17th of November, 3i Atlas is going to be in line with those sunspots again if they still exist. We could get a second flurry of energy sent there. And those solar flares, they release a lot of extreme ultraviolet X-ray radiation. That's the primary type of solar radiation that causes photoionization and plasmification of dust, grains, and also any sort of heavy ions with 3i Atlas. So that's really, really key. All the effects are here. It's really incredible what's happening with 3i Atlas, and we don't know what's going to happen, but it's basically creating this very large gas and dust and plasma plume all through this zone here. And then if we go forward in time to the 19th of December, we get the closest approach of 3i Atlas with the Earth right here. And if we go forward just a little bit more, we see that all of a sudden we get this alignment with all the planets. On the 9th of January, it is really nice like that. Look at that. That is a beautiful alignment. Mercury slightly off. 3i Atlas also slightly off. It's actually a little bit like a parallelogram right here, but a perfect alignment here. 3i Atlas, very electromagnetically charged. Again, that magnetic field, at least during a solar storm impact for 67P CG, was 300 nanotesla, but it was hovering around 50 the entire time, energized or not, just because of the solar wind pileup. So you have a significant electromagnetic force traveling through, and then we get this alignment, and this alignment, in fact, is lined up with where 3i Atlas originally came in from. Because if you look right here, and we just shift this over a little bit, we see that it is pretty darn close to its original position in Sagittarius. So it's not that far off from that constellation. Pretty crazy. Pretty crazy. Now this non-gravitational acceleration, I saw it first reported here by Avi Loeb, who is just on Joe Rogan. You guys may know of him. It's actually first reported by NASA JPL. We'll check out their actual data. But he did some number crunching in terms of basing it just off of, okay, if this non-gravitational acceleration is based off of sublimation and, gas processes, then it's going to be equivalent to like losing 1/6 of its mass. But he doesn't factor in any of this. And, I'm not the expert, okay? I'm just learning this as I go. But he didn't factor in any of the plasma stuff, as far as I know, in his calculations. It's really just like a gas-dust equation, like really just a gas equation. But we see that it's actually much more than that. Rosetta proved that. That's the latest data. Rosetta proved that. So I really don't, these values of it losing 1/6 of its mass through sublimation, maybe, I don't know. I think it's a little much. Just my intuition doesn't really tell me that that's accurate, but who's to know? But this non-gravitational acceleration was basically picked up from the data obtained by the Atacama Large Millimeter Array. And it indicated that 3i Atlas was 4 arcseconds away in right extension from where it was supposed to be on October 29th, if its trajectory is dictated by gravity and just gravity alone. So 4 arcseconds is pretty minor, because you have arcseconds, arc minutes, and then you have degrees. So it's pretty minor, but notable. And you can see those values right here by going to NASA JPL. This is for C2025 N1 Atlas, or 3i, third eye Atlas. Atlas being the repository of knowledge, the book, the Akashic records, right? Use your third eye, see into the future. It's pretty interesting. So here we have that, and you can simply look here. Let me go over here. Last observation used was the perihelion right there. And then we see, if you go down, we see the guy who ran the latest orbital calculations there. And we can see our, what's it called? Our non-gravitational acceleration parameters here. This is the radial acceleration parameter, and this is the transverse acceleration parameter. So these are the values, 1.66 times 10 to the negative 6 in astronomical units per day squared. And then this one's 7.08 times 10 to the negative 7 astronomical units per day squared. So there's basically always going to be some non-gravitational acceleration components. That's the thing. It's not like that's just happened on the perihelion. And it's like only on the 29th can it do that. It's been off-gassing the whole time. So it's really just like, now we have the latest measurement. How has that non-gravitational acceleration changed? Because it is receiving the most photoionization during perihelion. But as I reported, all the solar flares and solar storm impacts certainly cause a much bigger change to its plasma energetic environment than just perihelion. So it's how has its non-gravitational acceleration changed through that entire phase, going from the 21st of October up through the 30th? That's a good question. I'd like to see some research papers on that. I'm not sure people will put 2 and 2 together. People are very hesitant to talk about solar activity affecting comets and them being plasma and more. Don't ask me why. I don't know why. It makes no sense. But they are very hesitant to. Because again, look right here. It's beautiful. We see that big coronal mass ejection launch right to this comet when it was pretty close to this perihelion. Then it got walloped by it. We see actually quite a lot of solar activity. This is just one example. I could pull up a bunch of them. Shoots and Sean was a good one. And you can look at, there's one video actually from like 2010, I think it is, where you see a comet fly into the sun, and then there's a huge explosion on the other side immediately afterwards. And people are like, oh, it's just coincidence. It's like, I don't know. You see the thing flying like this, and then it explodes over there. Randall Carlson had that in his video. I need to pull that one up. I don't remember the exact date. I don't want to spend the time looking it up in the video. But that is what we have happening, and we still have these coronal mass ejections occurring. These sunspots are soon to rotate towards Earth. So here we have our coronagraph view, our CCOR1, and let's give this a look. We'll see this for the past 24 hours. That's Earth shine right there. That's Earth getting in front of the view. We'll see some big coronal mass ejections launch off, both from the south and also the first one's from the north. There's another one. So we have 3 big sunspots now about to rotate into view. Those are the ones that were pelting 3i Atlas with some of the biggest solar energy in decades. Solar storms and, solar flares. That's at least what we suspect. And we'll see these explosions, and you'll see the brightness rotating closer and closer. So it's loading right now. Well, this is only the past 3 hours, so we actually missed the latest explosion, but look at the brightness there. We do see some activity here, but this whole region is rotating in, and look at the coronal loops. So we have 1, 2, and 3, north, equator, and south. These big sunspots that are going to be rotating towards Earth facing, as I've been reporting. I think we have some pretty big solar activity coming in over the next week, 10 days. Here we have our helioseismic data. This is the latest, taken about 24 hours ago. And here we see these big 3 sunspots. 1, 2, 3. Yeah. So there were 2 when they rotated off onto the far side. 2 were pelting 3i Atlas with these big solar storms. Now we have 3. So we actually have potentially even more activity headed our way than what 3i Atlas received. So yeah, it's looking like it's going to be very intense. And that's it for today's video. So thank you all so much for watching. I've been your host, Stefan Burns, reporting from the spaceship, the 3i Atlas spaceship. We are blasting off to Jupiter. We are going to colonize Ganymede. It's going to be awesome. Getting ready to take over the solar system. So if you want to jump on board, well, you got to ask, and they may beam you up. They beamed me up last night. I wish you all a great and happy Halloween. The veil is thin right now. The energies are strong. So I just wish you all the best in terms of feeling these and feeling good and well. Make sure you rest and take care of yourselves. There's a lot of very powerful energies right now. And I'll keep you up to date with 3i Atlas and everything else as well, right? 3i Atlas is a curiosity. It's interesting. It's a portal into a whole bunch of different things, but it's certainly not the only important thing that exists right now. The solar activity story is much bigger in my opinion. And in addition to that, there's a lot of people capitalizing on 3i Atlas in terms of creating an alien narrative or just kind of spinning things around. So that's why I spent some time here, because I really just want us to understand like what's happening with the comet. Again, I don't claim to be any authority. I don't claim to be the best comet expert in the world or anything like that, even close. But I do have a good sense of just kind of where attention and focus is, and people aren't focusing on the complex, dusty plasma dynamics and the plasma environment of comets. Instead, they just think of it as, gas and dust, and that's it, I guess. I don't know. It's kind of surprising. Maybe it's too much for people. They don't want to go over people's heads, but I think people are smarter than we give them credit. So we should at least give it a try. And that requires learning about this. And I'll continue to learn about this as best I can so I can dig into this more and more, because what we observed with 67 PCG back in 2015 with Rosetta was fascinating. And I think what's happening now at 3i Atlas is probably even crazier. We just don't have the direct observational data. So a lot more to come. I'll be back with more videos, wishing each and every single one of you well. Please take care of yourselves. I'll see you all in the next video.